All right, so we're still on residual plots and analyzing residual plots. We talked about that when you're looking at it, you're analyzing how your residual, which is your actual minus your predicted, right? That difference, how it behaves around the x-axis. So you want it to be random. That's telling you that it's a linear model, okay? So if your residuals are random around your x-axis, that is going to be a linear model. If your residual values look like a U-shaped pattern, it's nonlinear, or it looks like inverted, it's also nonlinear, okay? So that's how you're analyzing. And again, your residuals means that you're taking your actual minus the predicted. If I do predicted minus actual, what is that? What is it? Error. It's an error. Remember, 8 backwards. Sorry, 8 backwards. I said 8 backwards.
Yeah.
Wrap it out. It is 8 backwards. Wrap it 8 backwards. EPA. Yeah. All right. So residual. All right. So we're going to keep going, computer. Clickety click click. So on to example 3. We're going to look at this data plot and look at the least squares regression line. So, and analyze the associate residual plot. What we're going to do is analyze whether the points are above or below. So this is the regression line that it says best models this, right? When you have a regression line, the residual values can be positive. So residuals can be positive, negative, or 0. Okay. When you have residuals that are above the line, they're going to be an underestimate. So like these right here, this right here, these are what we call underestimates.
Oh.
All right. Sorry for the Zoom little thing there. So again, residuals lie over regression line will underestimate. Underestimate. I think I spelled that right. Okay. And then when you look here, residuals that lie under, that little guy, they're going to be overestimates.
Because the line is what we estimated, and so if the point is here and we predicted it would be here, but we under.
Yes. No, we are. That's the color. So this is your overestimate. The blue, the red is your underestimate. So the actual values are the points, right? And this is our regression line. So if it's above the regression line, then the residual is going to be an underestimate. If it's below the regression line, then the residual is going to be an overestimate. Okay. All right. So your predicted line will underestimate. Underestimate. When a residual value is positive. And then your predicted line will overestimate. Estimate. When your residual value is negative. And that's again because residual equals what? Residual equals your actual minus your predicted. All right, so key things again for residuals. If we're reading just a residual plot, we want it to be scattered around the positive x-axis, okay? That's how we know it's a good linear model. If it is not scattered, but making some type of V or U pattern, that tells us that a linear model is probably not the best fit. Does that make sense? Okay, all right. All right, so we have this set of data and we're going to enter it into to our calculator. And determine its R squared value eventually is what we're going for. Wait, where are we at? Oh, we're done with that one, right? Okay.
For L1,